Today we're going to start talking about physical properties of pure substances, and then we're going to differentiate between those properties. So we're going to tell whether or not those properties are intensive or extensive properties of matter. First, we're going to look at the essential standard, which is 6.P.2, the same standard we've been on for about 2 weeks now, which is understand the structure of classifications and physical properties of matter. The clarifying objective is going to change. So our clarifying objective is going to be to compare the physical properties of pure substances that are independent of the amount of matter present, including density, melting point, boiling point, and solubility. So those properties that do not matter how much of that substance you have. And we're going to compare those to the properties that are dependent on the amount of matter present, to include volume, mass, and weight. So those properties that depend on how much of a substance you have. Our essential question is going to be, what is an intensive property of a pure substance? That is the first essential question we're going to focus on. So today and tomorrow we're going to take a look at intensive properties of pure substances. Then we're going to start looking at what is an extensive property of a pure substance. And then we're going to differentiate between what an intensive and extensive property of a pure substance is. First, we need to define what a pure substance is, and we've kind of already defined pure substances because we've looked at elements versus compounds. Element is going to be a pure substance. So a pure substance is a sample of matter that has the same composition and chemical properties. So all of these elements on the periodic table are going to be pure substances. They're going to have the same composition and chemical properties. So everything that you see on that periodic table when found by themselves are going to have the same composition and chemical properties. This is just another periodic table kind of blown up a little bit bigger. And just to reiterate, all of these substances are going to be substances that are pure substances. They're going to have the same composition and the same chemical properties throughout. So first, let's look at a physical property. Physical property of a substance is a property that can be seen without changing the substance into another substance. So if we look at this substance in the picture, some physical properties about it would be that it's gold. Okay, so it's color. That color can be, you can basically identify that with your eyes. So we're using one of our 5 senses in order to identify physical properties. We also can say that this sample of matter is shiny. So we're looking at its luster. Luster tells whether or not it's dull, whether or not it's shiny. Okay, we could also pick that piece of matter up and we could smell it and see if it gives off an odor. And odor would be a physical property of matter. Let's look at intensive physical properties. These are going to be properties that do not matter. It doesn't matter what the size of the sample is. It will always be the same. So if I had a big jug of water, its intensive properties or intensive physical properties would always be the same, okay? No matter how much of it I poured out or how much of it I kept. So an intensive physical property would be like solubility, okay? And we'll talk about solubility in just a second. Density, okay? So the density of water is 1 gram over a milliliter. It will not change no matter how much of that water you have. Water's melting point will always be the same. its boiling point will always be the same. And another one that's not listed up here is freezing point. It will always be the same. So no matter how much of that substance you have, it's always going to remain the same. Solubility, okay, that's a intensive physical property. It's the ability of something to dissolve in something else, okay? So a couple of days ago, we did a demonstration in class, and that demonstration was to dissolve an antacid tablet in water to see if it gave off some type of gas. And those substances dissolved in that water, and its ability to dissolve in that water was its solubility. If I were to put something into water and it did not dissolve, that substance is said to be insoluble. So for instance, if I took rocks and I put it in water, those rocks would not dissolve. They are insoluble. And the faster a pure substance is going to dissolve, the more soluble it's considered to be. So solubility is intensive, as it does not matter how much of the substance you have, it will either dissolve or it won't. So it doesn't matter how much water I have, those antacid tablets would have dissolved or not, okay? So it doesn't matter how much of the substance it is, it's still intensive. It still is either going to dissolve or not. The speed of dissolving is not going to matter on how much of the substance you have. It still is going to have the same speed, okay? So it's going to dissolve at the same rate. One of my favorite examples of solubility is Kool-Aid, okay? So if you're making Kool-Aid at home, you're stirring your cup of sugar and in some water, that sugar is going to disappear, and it disappears because it dissolves in the water. If it doesn't matter if you put 2 cups of sugar into the water, it will still dissolve. So one of my favorite examples is the Kool-Aid example, because you're going to put your Kool-Aid in there and your sugar into the water, and you're going to mix it up and it disappears. It dissolves into the water. So that sugar and that Kool-Aid is soluble. It is not insoluble. When we look at density, density is going to measure something's mass over its volume. So it kind of looks like, or looks at how much matter is going to be compacted together in a substance. So this bowling ball has lots of matter in it. And it's not how much something weighs, it's basically how much matter is in that bowling ball. So we consider a bowling ball very dense because those atoms are very tightly packed together. So remember, atoms of a solid are going to be very compacted together. If you take a look at the bulletin board around you, it's made of something we call cork. It's not very dense, so it's not very, the atoms are not very tight together. So something that has a very high density is going to have lots of matter compacted together in comparison to something that does not, such as cork. Density is intensive physical property because it does not matter how much you have, it's still going to have the same density. So water, no matter how much of it you have, its density will always be 1 gram over a milliliter. I want you to remember that. The density of water is always going to be 1 gram over a milliliter. So no matter how much water you have, if you were to measure its mass and its volume and divide the mass over the volume, you're always going to get 1 gram over a milliliter. So if you look at these bulletin boards, they are not very dense. The atoms are going to be very far apart. You can put a pin or a thumbtack into that bulletin board. You can't do that to a bowling ball because those atoms are packed together. They're too dense. So the thumbtack will not go through that bowling ball. Let's take a look at melting point. Your melting point is the temperature that a substance starts to melt. It is intensive because it doesn't matter how much of it you have, the temperature will still be the same at the time that it melts. So the melting point is an intensive physical property as well. If we take gold, I can use it because it's pure and it's on that periodic table. No matter how much gold you have, whether it be my wedding ring, don't tell Coach Strother I use that example, or a car made out of gold, or that gold block, it doesn't matter. If you heat it to 1,948 degrees, that's a lot, that's very, very hot, it's going to melt, okay? And when we melt that down, we don't really look at how much of the gold we have, we look at the temperature. So the temperature is the intensive physical property. So that 1,948 degrees, that temperature is that intensive physical property. Another intensive physical property is boiling point. Boiling point is the temperature that a substance begins to boil. When I return, I'm going to do these examples for you. So you'll start to see that the temperature of water, no matter how much we put in to the beaker, it's still going to be the same, okay, no matter how much of it we're boiling. The boiling point of water is intensive because it doesn't matter. We're still going to have that same temperature. It's going to boil at the same exact temperature every time. So if I boil water at 212 degrees, it's still going to, I'll say this, water is going to boil at 212 degrees every time, no matter if you have a gallon of water or a pint of water, still going to boil at 212 degrees.